Hi everyone, this is Zhong Wen. Today is April 7th, 2020. I hope this video finds you well and staying safe during this ongoing pandemic. So in today's video, I'm gonna briefly go through what I've been done in past week. So during this final month, I tried to spend time reading the surveys as planned and introduced by Dr. Liu and Dr. Che. So I think I made some progress, but not too much. So this week I mainly work on the Survey 7, which is also another heavyweight ACM survey paper among the 14 surveys on our website. I also keep notes with the details as well as asking asking myself 3 questions about is a survey help to me and what I like most from the survey and what do I dislike the most of the survey. So we can take a look at the survey. I think this is a very good ACM survey which published in 2019 last year. So it mainly surveys on the scheduling strategy for workflows in cloud environments and emerging trends. So from the very beginning, the author introduced cloud computing, especially introduce 3 kinds of service we can use. One is a infrastructure as a service, one is a platform as a service, and a software as a service. So it also introduced the basic things like the workflow models, the how we represent the workflows in a DAG, directed acyclic graph, and also it have a brief introduction about the traditional workflow management system. And what I like most is a taxonomy of the workflow models. And here it categorizes workflows into 2 categories. One is a synthetic, and the synthetic workflow is meant for the testing purpose, and the other one is a scientific workflow. And in the scientific workflow, it categorized in several categories, such as I/O intensive, CPU intensive, and memory intensive, and also introduce representative workflows. I think this is really helpful for the new researchers who can quickly maybe Google or get known to the most well-known workflows currently have. So this is one thing. And the second thing I like about this paper is it has many mathematic definitions. For example, like the how to calculate the execution time. And basically it's depends on the data size and also the calculation computing capability. And here the capability is consider the full utilization across all cores on CPU, which is not always the case, but I think this is a good start to analyze the execution among different tasks on different CPUs. So it also has some other mathematical definitions. I think that's really helpful to understand better how we will do the schedulings. So follow up, it introduces scheduling objectives like the different objectives such as the deadline, the budget, and the different things like availability and reliability and energy. So this survey mainly focus on for example, like the deadline, like the budget. I think it has a mathematical definition about the energy and energy consumption. Basically, it's depends on carbon dioxide consumption and also the temperature. So it has a formula to calculate that. And also, I think this paper is explained very clearly about the scheduling objective in these charts. So I think this chart is really clear and contains most information we need to know about the objectives. Also, it has so this graph is also objective. That's based on maybe this uni-objective or multi-objective. And then introduce some existing scheduling algorithms. And this part, I think here is a algorithm introduction section, and it introduces basically two categories. One is a static or dynamic. One is a meta heuristic. So you can see from here, the first part is introduce static and dynamic 5.2.1. So this part I think is a little bit structured, because you can see the author just stack all the algorithm together in several paragraphs, and without specifying why this paragraph had two algorithms, but why we put them together in a single paragraph, and why these two are put into the same paragraph. I think they're a little bit different. Maybe we can fine-grain the definition or classification. That would be more helpful. And this is a chart to explain, to describe or summarize the algorithm introduced. So I think this paper is quite clear and well written, but I also found a lot of typos, which takes some time to guess what it really means. And so here it comes emergent trends. So first one is a container-based. So this is a standalone and self-contained units that enable for the workflow execution. And I think this one is more interesting about serverless computing. The serverless computing is basically another name of API computing, or utilizing the API. So you can tell from this graph, you can see the traditional service-based architecture is basically the engine is interact between as an intermediate guy that operate between the storage and the service. So this has to fetch the data and then to give to the services and act like the intermediate guy. But for this case, like the FaaS, which stands for function as a service, and which is another name of the serverless computing. And this one, basically, it just utilize all the APIs in different APIs to execute different parts of workflow, or even just one task. So you can see there's an API gateway stand between the engine and actual functions. So it also has an external storage that to eliminate the data fetching, the time to fetch data. So you can see from below it has several types of serverless workflows, and also it introduced another interesting topic about the fog computing. I think this is a subtype of edge computing, and without involving any backend computing resources. So you can see the fog computing just consists some fork nodes, such as the sensor data, the IoT data, and the storage in the cloud. So basically, it tries to utilize the front-end services or the edge services for the processing the data. But there's a trade-off. There are some drawbacks, because the computation power of the front-end services or front-end device are not so powerful. So maybe we need to strike a balance between the computation, how big, how much computation we want to do, and with the sub devices. So this is a fog computing, and maybe in the future, I think if we're doing the edge computing, that's more generalized, because we can also utilize the backend computing resources. For example, like the deep learning or machine learning, we collect the data on the edge and pre-processing the data on the device directly. And if the computing power is not enough, we can send the data to the backend server to have intense computation, including the deep learning model training and prediction, and send back to the edge. So this is a future directions. It provides several things. I think that's also has insight for the workflow areas like the energy, efficient scheduling, like the dynamic QoS, and also the workflow prediction and runtime estimation. Also, there's another resource prediction and task scheduling. I think this is something we may do in future with our proposal, maybe to implement the deep learning or the machine learning, incorporate that with the workflow scheduling or workflow management system to help the either way, whether either to improve the workflows management system or improve the deep learning process. So yeah, so this is the first item. So let's go back to the slides. And for the LPOT journal version implementation, so if you watch a video from last week, I had an error when I tried to follow the instruction from Bai. And for this week, Bai and I worked together on several trials to debug the error on this executor beta.java. But until now, the root cause still not found and still not clear, and the error not resolved yet. So I also recommend Bai, and Bai is actively contacting and working with CNIT in Wayne State to resolve his remote VPN issue. That's time from time has issue to remote or set up the VPN with Wayne State University. I think I had a similar error before, similar issue before. So I think the root cause was because I was added into a wrong group. So hopefully CNIT can help him to resolve this problem, and so he can set up VPN whenever needed. So I think after IT helped me to resolve the issue, I have no issue anymore when remote from China, remote the VPN from China. So hopefully this will be helpful to him. And also for the following items, I don't have much updates, like the workflow on complex GPU workflows, like the Java converting the PHP file and ICATS. Have no big updates so far. So this is all I will talk about for today's video. Hope you enjoy, and stay safe and healthy, and stay away from the virus. Okay, thank you for your time. Until next time, happy coding.